So magnetic force on a current carrying wire. So in this class I am going to discuss if I place a current moving current wire, that means a conductor which carries a current I, if it is placed in an external magnetic field, so how much force exerted by this magnetic field on the magnetic force on this current. So let us take a small wire which carries a current I. Okay, so here I am going to place this moving current wire into an external magnetic field. So here my magnetic field is like this. If I write like this, that means the magnetic field is out from the board. So if I place this current in a magnetic field B, so how much force this magnetic field exerts on this current? So we are going to calculate that one. So here I is the current in this wire, and let us take a small length element dl, and d represents the drift velocity of the electrons, which is opposite to the direction of the current. Okay, so now let us see the relation between the drift velocity and the current I, that is I is equal to J into A. So I is equal to J means number of electrons passing per unit area, per unit volume in the wire, into A, area of the cross section, into E, charge of the electron, into area of the cross section, velocity of this electron into A, area of the cross section. Okay, so this is the relation between the drift velocity and the current, which is the relation between drift velocity and current. Okay, so here our aim is I am going to calculate the magnetic force on this wire, this moving current wire. Okay, so let us see. Okay, so where A is the area of the cross section, the force, see, if the force exerted on these electrons, so here in this current means the electrons is moving, right? The force on each electron on this wire is F is equal to minus E into V cross B. Okay, the force on the electron due to this magnetic field is F is equal to minus E into V cross B. So this is the magnetic force on each electron in the wire. So now let us take a small length element dl. So now we are going to calculate the force on this small length element dl. The force means magnetic force due to this magnetic field. So that is dF is equal to, so number of electrons present in the small length element, number of electrons present in the small length element is N dl, and area of the cross section of this length element is A into E, okay, V. So I am going to write directly as A V E into dl cross B, where I am going to take this dl length element is in the direction of the current. So now I am going to calculate this force in the direction of the current. So I am not going to write minus sign here. Okay. So next, so and dF is equal to, we know that NVE is nothing but I. Okay. So NVEA is nothing but I into dl cross B. So this is the magnetic force due to this magnetic field on this small length element dl. So which is magnetic force. So now the total force, if suppose I am going to calculate this force for a length wire L, that means if my wire length is L, so then the force, the magnetic force on this length wire is F is equal to I into, just I am going to replace this dl into L cross B. So this is the total magnetic force. Total magnetic force on this wire of length L. So F magnetic is equal to I into L cross B. Okay. In the next video, we will going to discuss line element current density, okay, continuity equations and some more concepts.